Hello, so I figured I could make a video about this because on April the 13th, on April the 13th, April 13th of 2024, we will have AWS Community Day in Kenya AWS Community Day. And we're going to have DeepRacer as one of the entries in that activity. Yeah, so let's talk about what is Amazon DeepRacer. DeepRacer basically is a virtual race. How you guys play Need for Speed or Forza Horizon, except it's different in that instead of just pressing left, right, and switches and acceleration, what you're doing is you're going to train a model, and then it's the model that will basically race the car for you. So the model that is most trained, the model that is the best trained is the one that wins, and that means it should complete the track in the shortest possible time without actually crashing. So it is basically a virtual race. And in order for us to start with this, we need to learn a little bit few things. Number one, it is a virtual race. Number two, you're going to use AI, and AI is basically artificial intelligence. Is basically machines trying to mimic human intelligence. And machine learning is a subset of artificial intelligence. It's a subset of artificial intelligence. So machine learning is basically you trying to training a machine to actually learn to make its own decision without being influenced. And subsets or types of machine learning are supervised learning and reinforcement learning. Now, supervised learning, from here you have raw data. Let's say you have data here, you have data coming in, and you have this particular model. Now, with supervised learning, you have a supervisor. So basically, you have a set data, and then with those set data, you label it. So you probably label it. So when you're giving in data, for example, stop sign, you want to train Tesla cars to actually know what a stop sign is. So you basically feed it images of images that are labeled, this is a stop sign. So once you feed it enough of those to train itself, now if you feed it another image of a stop sign without labeling it, then it can automatically infer from that. Now, unsupervised learning is basically the complete difference with this. Now, when you feed this data, you don't label that data. The model is supposed to come up with its own label depending on data. So you can cluster data. So you will have to sift through and look through that data and learn and basically label this particular data. Yeah. I don't have a scenario for something like that right now in my head, so I'm not going to struggle with it. And then the last one is reinforcement learning. So reinforcement learning. And basically the basic of reinforcement learning is this is an iterative process. Yeah. So a reinforcement learning is an iterative process. So it's an iterative process, meaning basically every time you create a model, you use the inference, what you have inferred about that model, feed it back into the model to fine tune it to make it better. That is what basically reinforcement learning. So every time you come up with, you infer something, you come up with this model is good. Now you feed back basically your inferences back into that model, fine tune it and make it better. Now also you have to make sure that as you train your data, you should make sure your model is balanced. Yeah, because some will come overfitted, and then some are underfitted. Yeah, so some will become overfitted, some will become underfitted. So what exactly are these? Now a balanced model is it is what we hope to achieve. This is a model that after we train that data and then we use some evaluation data, it works well. And if we transfer it to any other scenario, we are going to come up with with great inferences. Now, if you overfit a model, you basically feed it too much training data so that it's not learning but simply copying, basically coming one-to-one with the data that you have. Or if you have an underfitted data, then it's not trained enough so that it's underperforming on training as well as evaluation. So always aim to have a balanced model. It is the only way. Yeah. So what happens? So when you want to actually train a model, you will collect data. It's great to collect data. So great to collect data. and create collect data. So always try to give 80% of data, so 80%, and then you should always leave at least 20% of that data for evaluation. Yeah, so you should always aim to leave at around 20%. You can take 80% to train your data, take 80% for training, and then leave 20% of that data for evaluating your model, to make sure your model works the way it's supposed to be. Yeah, so with this simple process, let's talk about a few things. Now, some of the things we have is an agent. So when you have an agent, let's talk about an agent. So what is an agent? An agent is basically what we are training. Yeah, basically is what we are training, and an agent works inside an environment, finds itself in an environment. For example, now this is an environment. Yeah, environment. Yeah, we find agent inside a specific environment. Yeah, so we are training the agent to learn from this particular environment, basically. Yeah, so that is one thing you're supposed to basically learn. So we're going to talk about that a lot. Anyway, so with this, I think this is enough information to get started on AWS DeepRacer. So let's just go do that. Now let's do F11. Let's go to AWS DeepRacer. So if you open this place, for example, if you open AWS, now for the record, AWS DeepRacer is going to cost you money. So if you're going to do it, you better have credits, or you're sure that you can pay. So you're going to just do DeepRacer. So this is DeepRacer. So I'm going to show you a little bit. Now, if you go here on the left, you have a racer profile. So you can create your name, your racer profile, where you come from, and all that information about you. Yeah. And you have circuits. So we have virtual circuits. We have these are the circuits that you actually have. So it's basically like F1, basically. Yeah. So they're already closed. Winter race 2024 closed and stuff like that. We have community races that are around you. You can actually, after training your model, you can actually enter these particular races and then race to see how well do you specifically rank. Then this is my racer profile. Basically, you can go edit your profile and give your name whatever it is that you want. Okay, so your garage basically shows the kind of cars that you have. So personally, the original DeepRacer car, and then this, I have this. So this is one that I upgraded. So as you can always build your new vehicle, mod it, make it, customize it the way you want. Now, one of the things that we want to do here is a model. So we want to train a model. So this one is still training. So I was hoping that by the time I show you this one will finish training so that you see what happens. So let's create a model. So now we want to create a model. So we're going to DeepRacer. So we're going to create a model for you. DeepRacer model. You're going to create model. So you can say this is a DeepRacer model. Yeah, and then you're going to pick let's say a specific highway. So do you want Vivalas, this one, circuit, this one, or that? Now you can pick any of those. Yeah. Now one thing when we talked about a balanced when we talked about a balanced model. Yeah, when you train your model on this particular track, a balanced model will aim to, when you train it here, it should work well when you go run your particular when you run your virtual car on this speedway. It should work better, it should work well, or here it should also work well. So you aim for a balanced, if you overfit a model, it will probably work very well here, but if you put it on this particular track, it's going to embarrass you. Yeah. Okay, so here track direction, where you want to go clockwise or anti-clockwise, that's okay. Now training algorithms. So there are these two training algorithms. You need not worry yourself with those. There are also hyperparameters that you can actually change. Now I would say just leave those at default, because if you make them higher, you're probably going to get charged more. Gradient, batch size, learning rate. Basically when you do your learning rate is basically how fast do you want your model to actually learn. So if you give it a bigger value, your model will learn faster, and it's going to take probably less time to actually train your model. And the problem is, if your model is learning faster, you're probably taking in more compute. And more compute means you're probably going to get charged more. And then we have things like entropy and discount factor. So leave those the way they are. Yeah, number of experience episode between each. Now, but if you're somebody who is who is great with machine learning and you're not a beginner, then these are things that you can customize. Because the aim is to train your model, is to fine tune your model in a way that it comes. Now we have type of race. So time trial. So time trial, when you're going to train it, it's going to be the agent race against a clock. So are you going to train it based on time, or are you going to train it with objects in the track so that it tries to escape objects, or are you going to train it with other cars racing against them? So those introduce more variables for it to train on. So yeah, you can do that. But obviously time trial is the simplest, probably definitely the most cheapest. So you pick which one you want. Like I said, if you're somebody who is good, machine learning is something you've actually mastered, then you're good to go. I'll just go with the default. And then you can pick action spaces. Do you want a continuous action space that allows the agent to select an action from a range of values for each state, or you do want a discrete space? I'm going to go with continuous. And then you can, what steering angles do you want? Do you want it to make it 35 so that it knows? So this has to go between 30, basically 0 to 30, 0 to negative 30. So you pick. I'm going to leave those as default. Then minimum speed. So you're going to say, okay, what minimum speed do you want it to do? So what if I want to do 1 meters? Value is between 0.1 and 4. Value between 0.1 and 4. Can be less than maximum speed. Minimum speed can only be less than maximum speed. Oh, this is minimum speed. Okay. Minimum speed. Let's say minimum speed is 1. Maximum speed is 2. Good. So you're basically increasing this. Then we go here. You're going to pick yours. Are you going to use the original or what? This is one I customized called Cybertruck, and I think I added LiDAR sensors here. But I'm going to go with the original DeepRacer for this particular. Now, this is one place that you can actually, that makes probably the most, this is one place that probably you can customize a lot. You have what we call a reward function. So let's talk about how your reward function actually looks like. So if you have a track, we have a track here. We also have a track here, for example. And then we have oh, sorry. Okay, let's just do track. So this is a track going this is the end, this is the end. So we have basically middle of this, middle. So what we're going to do, this is how this function talks about. So this is a reward function. So when you have a reward function, every time you're training your agent, you can reward your agent when it's doing something good, and you can punish it when it's doing something bad. That way it will learn always to do something good so that it gets reward. That's how you train dogs and stuff like that. So that is how you can also train here. So this is a Python function that says now you can find a way to actually make yours better and fine tune it, but this is the default that you're given. So define reward functions. So read input parameters. So we have track width. We have the track width, so the width of this particular track. Yeah. And then distance from center. So we're also defining distance from center. So distance, this is the center, distance from center. So we have probably our, this is our vehicle, this is our car, this is our agent. The car is the agent in this case, or the car. Yeah. So you can also call it car. So this is the car that is our agent. And then, yeah, so calculate 3 markers that are varying distances away from the center line. So we are defining three distances away from center. So from center here on either sides. So what do? We say marker 1, which let's call it, and then we give it 0.1. So that is 0.1 from center. Marker 2 is 0.25 from center, and marker 3 is 0.5 from center. So it is further out. Yeah, so after defining that, now we are going to give our reward. So we say if distance from center is less than or equal to 1 closest, you give a reward of 1.0. So it means every time the car is closer to the center, you give it more reward. If you give it distance from center, marker 2, which is if distance from center is less than or equals to marker 2, and marker 2 is 0.25, you give it a 0.5. That is a lesser reward. And if distance from center is marker 3, which is 0.5, you give it a reward of 0.1. So that is the least reward. So the car, every time the car is being trained, every time it ends up on the edge, it's going to be deducted, and it's going to figure and realize, okay, every time I go here, I get deducted, so I should always stay within the center line so that I get maximized. So that way, your car does not crash when it goes through corners and stuff. And that's how you train. So this is what your reward function is like. So you can tweak this basically how much you want. So when your training has stopped, you'll be able to clone your time. Oh, I gave my training 30 minutes. Let me try and give mine. Depends on how much you want. You can give it 30 minutes. Now the more you train it, probably the better it becomes. So this is qualifier. So now here, in case you want to submit it to that race immediately. If you don't want, that's okay. Then you now create your model. Now you create your model and you sit back and wait for your model to train. Now this is going to take a little bit of time, 30 minutes. So I can come back here to my model and talk about test model. So this is the test model that I was training, and it hasn't finished training. So what happens is, you can see here, let's look at the graph. So we have a graph. Now you can see this vehicle is training. How far is it trained? So we have average time training, average percentage completion, and average percentage completion evaluating. So you can see graph. So we have reward against iteration. So this is iteration 1 with this graph, second iteration, third iteration. So it's training and getting better. So at this point, you see it's moving around track. It's moving in the middle. When it was beginning, you could actually see. When it was beginning, you could actually see the car was actually going off. It was basically going off the rails. Let's see if we can find the same one here. Let's go back here to my models, and then DeepRacer model. Let's try this. Is this showing? This one still isn't show. This one still isn't showing. The original. The video. It's going to take a little bit of time to actually start streaming that video, but now you basically get it. Now once you're actually done, here's your model. So for example, here, training test model. So once you're actually done training, this is going to go on for the next hour. This is going to go for the next hour. It's probably going to this is going to go for the next hour, because I gave it 60 minutes. Now after that, you're going to go to evaluation. Yeah, so I'm going to create start and evaluation. So it's obviously grayed out right now because training hasn't finished. So when I go to evaluate, I'm going to click and open an evaluation. And evaluation is basically using you're using let's say the 20% of data to actually test if your model actually is it balanced? Can it run on the second track the same way it could on the first track? Yeah, so you basically look at that, and if your model works okay, then you check. So if you're satisfied with your model, you can go enter community races, and then or you can go into community races, and and basically you can play community races, and you're good perfectly. Now that's basically that is basically how you do AWS DeepRacer. That is exactly how you do AWS DeepRacer. So I hope this actually helps you get started. Like I said, make sure this actually takes money. So know that this actually you're going to be charged a little bit of money. So I just putting it out there for you. Otherwise, if you do have any questions, you can comment below, and I'll probably try to help and figure it out. Otherwise, if you're going to enter into AWS DeepRacer challenge, well, good for you.